if you notice, we're going to decide that we're not doing seasonal forecasting. It's pretty difficult. Other than we're going to glance at it. It won't be on the final. But part of it, this other forecasting technique, is the only new thing we're going to talk about today. The rest of this is pretty much going to be review, but it's going to be kind of a quick review because all my questions are going to be related to that picture right there. Let me make sure I got a good picture of this. Well, I don't know if I call that good. You ready?
Is the exam going to be just the regular 4 to 5:15, or is it longer?
4 to 5:15.
Time frame.
Oh, you mean like 4 to 5:15?
How long is the exam?
2 hours, at least 2 hours. Probably 2 hour time limit depending. And like half of it's just like a quiz over, like you have the 2 chapters, 12 and 15, spread out throughout the final. The other half of it is like one question from, however many chapters from the past, that would equal another hour. One from each chapter, which we're going to talk about today to try to limit you having to study the whole chapter of every chapter. But I got to get you prepared for chapter 15. One of the techniques we talked about is moving average. All right? I want you to look at the rules for moving average real quick, and you'll see if you wrote down all the rules that it says whatever number of periods moving average is being asked, that's the number of periods you use previous to the period you want to forecast. So the question could be stated all kinds of different ways. But let's pretend I'm asking for a 3-period moving average technique to be used, and I want you to forecast period 7. Forecast period number 7. This is the data. My question for you is, what periods will you use to calculate your forecast to answer this question? 4, 5, 6. The 3 periods that are before the one being forecast. That's it. You would add those 3 periods up, divide by 3. That's moving average. Add them, divide. Let's do another one. This is now a 4-period moving average, and I'm asking you to forecast period 13. Don't let me throw you a loop. I'm asking you to forecast period 13. What are the periods you're going to use? Say it again, loud.
9 through 12.
The 4 periods just before it. Now, I just asked you to forecast a period that's not there. It's a forecast from the future. As long as there's the number of periods with real data available based on however many periods I'm asking for, it can be done. Now, I'm not going to throw you a loop and go, hey, everybody, forecast period 14 using a 4-period moving average, because that's impossible. You'd have to have 4 periods right before 14 with actual data, and there's not one on 13. You can't do it. I'm not going to try to trick you and do something like that.
No, we can't do 0 or 2.
No, we can't do 0. All right, so we'll make sure we have this down. I'm asking you for a 2-period moving average forecast, and I'm going to ask for period 4, for forecast period number 4. What periods are you using? 2 and 3. It's a 2-period. So I'm asking for 4. You go the 2 periods just before 4. I'm going to throw a loop on this question. For the record, for the recording, Thomas E. Isley. No. You ready? I want you to use a 3-period moving average to forecast the very first period you're able to forecast that can be compared to actual data.
You said 3?
Ready? 3-period moving average for the first period you can do a forecast for to compare to actual data. What period are you forecasting?
4.
4. Because I asked for a 3-period moving average, you have to have at least 3 periods of data. You can't do a forecast for period 1, or 2, or 3. 4 would be the first one you could do one for and compare to actual data. So that's how you know you're going to do a forecast for period 4. And you're going to use what 3 periods?
1, 2, and 3.
1, 2, and 3. The 3 right before 4 in that case. Okay, we're changing the scenario now. Only thing I'm changing is the word weighted moving average. These questions should have a lot of the same answers if you understand this. All right, by the way, that moving average was all about adding the periods that I'm asking for and dividing by the number of periods that you have to use. This one is not divided. This is using the number of periods being asked for, multiply them by their weights, then add them together. But other than that, the rules are the exact same as moving average. For example, if I said to you, I want you to use a 3-period weighted moving average and forecast period number 7, what periods are you using? I heard it, someone whispered it.
4, 5, and 6.
4, 5, and 6. The 3 periods right before the period I'm asking for, no different than moving average. The same answer you gave me for moving average. The only difference is, I said weighted moving average, your calculation is different. But the periods you use, no difference between moving average and weighted moving average. So I'm going to ask you now, 4-period weighted moving average, 4-period weighted moving average, forecast forecast period 13, same as before. 13, what periods are you using? 9, 10, 11, 12, the 4 periods that are just before the period I'm asking for, even though the period I asked for is in the future, this concept doesn't change. It's the exact same. We have one more. You're using a 2-period weighted moving average. You're asked to forecast period 4. What periods are you using? I heard it.
2 and 3.
2 and 3. The 2 periods just before whatever it is I'm asking for. But this time you're going to take the weights that are given to you. Let's practice one of those. I can see by the look in some eyes. Weights being given to you. Okay, here we go. 3-period weighted moving average, and the story might say use 50% for the most recent piece of data. Use, I don't know, 40% for the oldest piece of data, and 10% for the middle, or it may say other. The logic will pretty much put into play what that means. It'll be logical. So now, I want to make sure you got this. I'm going to ask you to do a 3-period weighted moving average for week 6. Week 6, I'm going to start with 50% times what? Go ahead, give me a number there. You're doing weighted moving average, 3-period for week 6. Say you get 0.5 times what? 18. The one from the most recent period before the one I'm asking you to forecast, because you're using the 3 previous periods. Then you looked and said, oh, 50% of the most recent. So the most recent piece of data before week 6 is week 5, which happens to be 18, plus 0.40 times what piece of data, what number would be right there? I got to look myself. Go ahead. Nope. No, here, but I heard it over here. 19. Because it says 40% times the oldest piece of data, and I think you said some other number than 19, right?
Oh, I just meant like the week.
So 19 would be 3 periods before week 6, or 5, 4, 3. Week 3 would be the oldest, which happens to be 19. Now it says use 10%, 0.10, times the middle for other piece of data, which would be what? Give me the number here. 23, the one between the 19 and the 18. Is that right? Is that right?
Yeah.
You would multiply and add. That's the only difference between moving average and weighted moving average, is that this one you multiply and add. The other one you add and divide. You're just finding the average. You don't have weights. Those are the two that are supposed to be give me points on this final exam. Give me points. But I thought forward pass and backward pass would give me points. So I don't know how to judge this. All right? I'm going to try to make, if there's a question about moving average or weighted moving average, the question's being written in a way that's supposed to be the confidence building giving points if it's on them, okay? I'm not going to try to throw you tricks or curves.
So for moving average, for 3 period before 5, 6, you add them up and divide by 3.
That's right. If I'm asking for week 7's forecast. Yeah, 4, 5, 6, add them up, divide by 3. That's moving average without the weights. Okay, so we reviewed moving average. We reviewed weighted moving average. Exponential smoothing, same data. Same data. The difference now with that exponential smoothing is somewhere in your notes about exponential smoothing, it should say you got to start at the first period. And you got to work your way down. You just can't jump down like with moving average to, oh, you want period 7, 3 periods, I'll just use the 3 before it. In exponential smoothing, the forecast always builds on the previous forecast. Builds, builds, builds. So if I'm doing a question on exponential smoothing, I have to give you a smoothing constant. We're going to use 0.4 being given to you on the final exam. And then it's going to say, give me an exponential smoothing forecast using the smoothing constant of 0.4 for period 3. For week 3, this is our forecast for week 3. We have to start at week 1 because this is exponential smoothing. And the forecast for week 1 is what using exponential smoothing for this data? 17. Rebecca, why is it 17? That's right. In exponential smoothing, you can't make a forecast for the first one. And so it says, you should have in your notes, always start with the first actual. So you're just taking whatever the actual is for week 1, and there's your forecast. So we got that one, but we had to do that to build to get to that week 3, like the problem says. Week 2, you've got to start with the work. So week 2 says, take your smoothing constant, which is 0.4, multiply it by what? Number or description? I'll take anything. 17 is the number. What's the description?
Week 1 actual.
Previous period's actual. Since this is week 2, we're looking at the previous period, week 1. The actual's right there, 17. Plus the opposite of the smoothing constant. 1 minus 0.4. 0.6. Give me in words or a number what goes right there for the week 2. This is a 2. What goes right here? Words or number? The previous period's forecast. That's what goes there. And the previous period forecast, we're doing week 2, so what was week 1's forecast? 17. Always kind of works out this way. Excuse me. If we do the math on this, there we go. It always turns out this way. You can almost assume it. To show the detail as to why we got this. Here's where all the points are now. I heard it.
So you got a 0.6 on.
0.4,
Yeah.
you have to use the opposite, 1 minus 0.4. They have to add up to 1 or 100%. They have to add up to 100%. Third week. This is the one where most of the points are at. What you did here was so easy, it just gets you to where now you can finally show me you know exponential smoothing. 0.4 times what? What goes there? 21. But keep it up. I know this is the last day, but please keep it up, even in your other classes. I don't care if it's wrong. I appreciate your participation, wrong or right.
You wrote 17.
Yeah, you wrote the wrong number. You wrote the wrong number to follow that up.
There we go. Okay. 0.4 times 21 plus 0.6 times what?
17.
Because you're using what?
The previous.
The previous what?
Forecast.
Forecast. The previous period forecast. I'm going to put an arrow here so you can see where it came from. Previous period forecast. You're always taking whatever this equals is going to be used in the next period if I was asking you for period 4. And whatever this equals, we're done. Because the problem said, give me a forecast for week 3 using exponential smoothing. You had to get a forecast for week 1. You had to get a forecast for week 2 to be able to get to the meat and bones of this question, which is period 3's forecast.
But so if we were to do period 4, we would do,
Here we go. She wants period 4, 0.4 times, give me the number, diamond.
23.
23 is correct. And then plus 0.6 times what? Well, I don't know. What's this equal?
Oh, so it would not.
What is this equal?
10.2.
10.2? No.
18.6.
No, it's got to be like 18 something.
18.6.
18.6? Confirm someone.
Yeah.
Anybody else? 18.6. So now that we know what this equals, this is what would be used here, 18.6.
Oh, so it uses the equal.
Whatever the forecast is for the previous period has to be used, and these have to build on each other. So if you make a mistake right here, and I'm asking for period 4, there's no way of getting period 4 correct. I have to pinpoint where you made a mistake.
If we're forecasting week 4, don't we multiply the 0.4 by week 3's actual?
Week 3's actual is not 23? What's going on here? Man, I gotta stop trusting them.
Well, it said 23. What are we looking at?
This is week 4's forecast. Thank you, Rebecca. And you have to look at the previous period's actual. So week 3's actual, it says 19.
Oh, okay.
Then the previous period's forecast time opposite.
Okay, well, I didn't know.
Okay, that's exponential smoothing. So we talked about moving average, we talked about weighted moving average, we talked about exponential smoothing. Now I posted this over the weekend. Where is it? This is all about MAE, MSE. Mean squared error, mean absolute error. These two errors. Without a doubt, one of them is on your final exam. This is so important. This whole chapter isn't about just how using forecast. A lot of emphasis is on how to figure out which forecasting technique to use, which one fits my data the best. By doing this process and keep checking your forecasting technique, you end up then raising the probability that your forecast is going to be darn close to what really happens. You want to increase those odds and put them in your favor, and that's why you're measuring the different techniques. Now, you cannot compare one technique to another using two different errors. You can't say, let's do this one and get the MAE, let's do this one and get the MSE. You have to either compare both of them MAEs or both of them MSEs. That's how you're getting them apples versus apples, is by using the same error calculation. So, and then let's say you calculate it, you got an MAE 4.4, and the question says, now whatever MAE you calculated, compare it to 5.0 of another technique. Which technique would you recommend? The MAE of 4.4 or the MAE of 5.0? Which one? I can't hear you. 4.4, why? The lowest. Whether I was asking about MSE or MAE, the lowest is the right answer. And in real life, when you're comparing different techniques to the data that you have to forecast, and it's going to happen first to accounting majors, you're the first ones that are going to be forecasting when you get a management position. You want to make sure you always pick the lowest. You're either comparing the MSEs, MAEs, or whatever you're comparing, it's always the lowest. That's the one that's going to give you the best odds that your forecast is going to turn out to be darn close to what happens. So here is how they're calculated. No matter how these forecasts were calculated, that's not what this is about, because we didn't learn this technique. This is all about how did we get to these two numbers that allowed us to get here. These two numbers. So whatever technique was used, you got forecast, period. You subtract actual minus forecast or forecast minus actual. It doesn't matter which direction you go. You can't get this wrong. 13 minus 18, negative 5. 16 minus 13, 3. 11 minus 16, 17. 14 minus 13, blah, blah, blah. Let's say I'm asking for the MAE. Now, you take each one of those errors and get rid of the negative, called absolute value. The negative 5 turns into 5. The negative 5, the negative 3 turns into 3. They're all positive numbers now. Add them. 5 plus 3 plus 5 plus 6 plus 3 is 22. Divide by how many we had. 1, 2, 3, 4, 5. You just calculate MAE. That's the process no matter how these came about. No matter which technique's being used. It's always about the error, the absolute value of those errors, added together, divided by the number you had there. However many errors you use. There's MAE. MSE. You don't need this column. This column doesn't even need to be done. Don't let it fool you. MSE is all about this column. You don't need any of these. This column. Here's our actual. Here's our forecast. Subtract 13 minus 18, 16, 11 minus 16, blah, 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 blah. Square. Negative 5 squared. The negative's gone. So if you get the negative wrong, it's going to be gone anyway. Negative 5 squared. 3 squared. Negative 5 squared again. 6 squared. Negative 3 squared. Negatives are all gone. Add your squares. 104. Divide by the number of squares you're using. 1, 2, 3, 4, 5. You just calculated MSE. These are all very simple formulas. The key is that when you get this question in front of you, that you have good step-by-step what to do. You follow your step-by-step based on these directions that you're getting here, you can't get these wrong. And you're getting tons of points, even if you make a simple little calculation error, you're still getting tons of points. You're setting it up correctly. It's all about the setup, that you understand the concept. Show the detailed work, you're setting it up. So we got MAE, we got MSE. Jump in, Jason.
What are the
Yeah, don't want to worry about it for your final. Yeah, I don't want to. You guys only have so much room. We, all of us as humans only have so much room. And that's why I use a planner.
We're going to get a similar color down the final.
You will get something maybe similar to this, except for you're only going to have these two columns. None of this will be here. Just these two columns. You got to come up with that error, and then you got to decide if you're using the absolute value or the square of each one.
So we're going to get the forecast.
I'm sorry, what?
So we're going to get the forecast.
You probably will get the forecast, because I don't want one problem to be where you have to do these forecasts, then calculate the error. I'd rather have those be two separate problems.
Right.
One where you're going to be the forecast, another one where you've given forecast and you come up with the error.
So in in what situation would a squared forecast error be lower in value than absolute value forecast?
No, you never compare these two with each other. It's all about comparing the same error technique with another forecasting technique, the same type. So if I were to compare whatever forecasting got these with another forecasting technique, and I calculate the MSE, I have to calculate the MSE for that one also. Then you compare, so you're comparing apples to apples. If you compare these, MAE will win every time. I know, there's never will you have a number that's bigger here than there, but you never compare these. You always compare MAE to another MAE. All right, so now, we only got two more to review. No, I'm sorry, only one more to review. Then we are learning a new one. Then we're getting to our extra long, heavy-duty in-class assignment. What? 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 You better get going. How are we doing that time? All right, we're back to the data. Back here. It shrunk on me. Hang on. Here we are. And the question says, use this data to calculate the slope and intercept to be prepared to do trend projection forecasting. Let me repeat the question. The question is, you're going to see a picture like this, maybe, something like it, maybe. It's going to say, use this data to find the slope and intercept to use trend projection to find forecasting. All I'm asking for is that slope and intercept if I'm giving you raw data like this. Now, if you look at your notes for trend projection, somewhere in there it should say, set up your 4 columns. 4 columns. 2 of them are set up for you. You just have to finish it. This one, what letter would you put on top of this column with the basic formula for slope and intercept? What letter variable would you put on top of this column? T. This is time. Week 1 through week 12. What letter would you put on top of this column? Y. These are the actual data, not the forecast, the actual data. Add your T's, 1 plus 2 plus 3 plus 4 plus 5, all the way to plus 12. This is, you just found that, the sum of T, by adding all these up. Then, you add these all up. 17 plus 21 plus 19 plus 23 plus 18, so on, so on, so on. That is the sum of Y. So now we found 2 of them already. We need 6 numbers for these calculations. And there's 2 of them, just adding these 2 columns. There's 2 more columns we need. I'll take either one of them. TY. She wants to do TY next, which is T times Y. 1 times 17. Hang on. TY. I'm just going to do a couple of them. 1 times 17. 2 times 21. 3 times 19. What is that? 57? Anybody? 3 times 19, is that 57?
Yeah.
Thank you. And so on. 4 times 23. 5 times 18, and so on. This is your YT column. When you add up that whole column, you found the sum of YT. Or TY, I don't know how it's on your formula, but it's T times Y, the sum of that column. This allows, I want to make sure you know why we're doing this step. This allows the trend to have more weight on the most recent data. Look at this, 12 times 22 is a big number compared to 1 times 17 or 2 times 21. It allows whatever's happening most recently to have more influence on our trend that we're about to forecast than the past does. They're all part of it, but it puts a lot more weight on the most recent, what's happening now. We have one more column. Anybody want to tell me what that last column is? T squared. T squared. You go to the T's and you square them. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. I almost said 12. 16. 5 squared is 25, and so on. 12 squared, 144. 11 squared, 121, and so on. Whatever. Then you add those all up, and that's the sum of T squared. So you got the sum of YT, the sum of T squared, the sum of Y, the sum of T. There's your 4 columns. Now there's only 2 more numbers we need. Only 2 more numbers. the mean of y, the mean of t. Let me put those up here. It's represented by a line over it. There's the y and a line over the t. The mean of mean. All you got to do is take, you've already added up all the t's. Right there, the sum of t, and divide by the number you have there. Divide by 12. There's the mean of t, whatever that equals. The mean of y, we added all these up also. 17 plus 21, all this. And we divide the total by 12. And there's the average, the mean of y. So now we have all 6 numbers. All 6 of them. I didn't put the formula up, but I know it's going to be easy to find. It's such an important formula. Didn't dawn on me I'd want it, but there it is. Right up there. Are you ready? The numerator says, forget all that stuff in there. What it's saying on the left side is the sum of ty. Right, where is that? Right there. That number goes on the numerator left. Minus the sum of t. Right there. Times the sum of y. Right there. Divided by n. How many periods do we have? How many weeks of data? 12. There it is. The denominator, here this gets a little tricky. The sum of t squared. That's this one right here. Minus the sum of t, long pause, squared. That's not the same one. That's this one. The sum of t squared. Remember, this was squared, not the same number over here. This one. Divided by the number of periods again, 12. Plug that all in. Watch out for your order of operations. Remember, exponents, inside parentheses, blah, blah, blah. Watch out your order of operations. Do the math on it, you get your slope. You just found your slope. Now you jump down to your intercept. It says the mean of y. We found it right here. We have the sum of y divided by 12. Then it says, be careful, minus. Now, if your slope's a minus, this is where everybody makes a mistake. The formula is minus the slope times the mean of t. If that's a minus, then do whatever you have to do to realize if your slope's a minus, they're going to cancel out and be a plus. So just be careful here. The formula's a minus, not this one. The slope, which we just calculated, times the mean of t, which is right here. So we have everything we need to find the slope and intercept. Now, if I were asking you to do a forecast using trend projection, I might already give you all 6 of these numbers. You don't have to do that part. This part is showing me you can come up with the slope and the intercept. If I want to see if you can use the slope and intercept once you have it, I'm going to already take all that work out of the way and just give you these totals. The sum of t, the sum of y, the sum of ty, the sum of t squared, and the mean of t, and the mean of y. The 6 numbers. Then I'm going to say, here's those 6 numbers you need. Forecast period, what do we have, 12 periods? Forecast period 14. Now you don't have to come up with all these sum ofs. You just got to plug these numbers in, plus the other 2 means, and get that slope, get the intercept. Now use it to forecast. And the forecast is, well, I'm sure it's on the next page, but it's, it's the, what is it, the intercept. I'm trying to think, what's the letter for the intercept? B sub 1?
VO.
VO. It's VO, intercept. This one's plus. This is your forecast. Not to find the intercept's a minus, but the forecast is plus the slope times whatever period you're forecasting. So what period did I say I'm forecasting? 14. I'm going to plug a 14 in right there and multiply that times the slope and add it to the intercept. So whatever that is. Here's the, I want to emphasize this again. If you're being asked to do a forecast, it's a plus right here. The intercept plus the slope times the period in which you're forecasting. If you're asked to find the intercept, the slope of the intercept, you've got to make sure you realize the intercept is minus the slope times the mean of t. This is where everybody can kind of make a mistake. It's because that one's a minus and the forecast is a plus. Want to confirm the forecast is on the next page. There it is. Again, right here. It's not a variable, but they're taking the intercept plus the slope times whatever period you're trying to forecast. In this example on page about 678, they said, let's find a forecast for period 11 on this data. The intercept 20.4 plus 1.1 times 11. Multiply that first, then add it. The forecast for period 11 will be 32.5. The best part about this particular technique is that it allows you to forecast into the future any period you want, but don't go too far in the future because you're losing that probability of it being most likely accurate or close to accuracy the farther out you go. So I used to only use this, most of the time trend projection fit my data the best. And I have to forecast the next 5 years. But once a year went by and I got to go now another year past, I check to make sure it's still the best technique. And then I'll forecast that additional year. But if I were to go on and do year 6, 7, 8, 9, 10, I could do forecasts for any period. But the farther out I go, the riskier of it being accurate is. Really, the trend projection's all over it for the first 2 or 3, 4 periods out from whatever periods you're projecting from. Once you go past that, you can do them, but you lose the chance of them. So you always want to reevaluate. If you have it on a spreadsheet, it doesn't even take that long. Okay, we reviewed trend projection now. Where does that put us? I guess that puts us here. This is it, the new stuff. The one new technique you're going to learn today. Here it is. Hang on, let me get there. Whoop. Whoop. There. Okay. Hey. What are you telling me? Can you see it okay? Because I can't get rid of that blue background. Somebody show me after class if they're all over this. I tried everything. Can you see the numbers? Whoa. Can you see the numbers?
Yeah.
Ignore all of this from here to the right. This is seasonal forecasting. We're not going to do it. But in this column, we are learning. Right here. It says moving average, but if, by the way, if you downloaded the PowerPoint, you want to re-download it because I added these slides to the video. Instead of doing it right out of the book, I wanted you to see an example. Centered moving average. What's different about centered moving average compared to moving average or weighted moving average is that whatever amount of periods you're using, you are using those periods averages for the center period of the period you're using to calculate. For example, look at where the first forecast is at. Period 1, 2, 3, 4, where's it at? What period is the first forecast at?
Year 1, season 1?
Year 1, season 2, I think is the first forecast. Right there. These are your actuals, these are your periods. Matter of fact, let's number these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. And I'm just going to number them 1 through 12 because this is the most recent and that's the oldest. This problem says, do a 3-period centered moving average. Did I write that down? I'm running out of room. Do a 3-period centered moving average. So, 3, 3 period, this is worse. Centered moving average. Make sure you get this. Let me repeat it. Whatever period you're forecasting, that period's the middle of the data you're using. Dylan, you're all over this. Let me say it again. I know you are, right? Whatever period you're asked to forecast, the data you use, the forecasting period has to be in the middle. So for example, don't forget this is 1 through 12. So what number is this right here? 1, 2, 3, 4, 5. If I ask you to do a 3-period centered moving average, and I want week 5 or period 5 forecast, think about this. What periods would you use to find that forecast? Fill it.
Would be 4, 5, 6.
4, 5, 6, because 5 then's in the middle. 4, 5, 6. So in this case, 1995, the 4th period down, 2168, the fifth period down. 1072 is the sixth period down. Those are the three periods, because it's a three-period center moving average, and the period you're forecasting for has to be in the center of the period you're using to make your forecast. And here's what happens. Let's jump back up to this first forecast. The reason that's the first forecast in period 2 is there aren't three, we can't get period 1 in the middle of anything. There isn't one above period 1 to make it the middle on a three-period moving average. Centered moving average, excuse me. So we add up the first three. 1856, 2012, 985. Divide by 3, we get 1,617.67. We line it up with the center of the three periods we were using, which is period 2. Shift down 1. Now we're not using that top one. Instead, we're jumping down to period 2, 2012, 985, and then this one, 1995. We add those three, divide by 3. We just forecasted the period in the middle, which is 1664 in the third period. And we shift down. Fourth period, shift down, fifth period. Everybody get it? Notice we don't have a forecast down here. There is no way this could be in the middle of three periods because there's nothing below it. So this is the last forecast we can do because we have 1, 2, 3 of them here, and the middle is right here. So now, I want to make sure you're getting this. This time, Diamond, if I said, I'm going to tell you which week to forecast or which period, and I want you to tell me the numbers used, not the periods being used, but the numbers you would use that you would add up and divide by however many periods I'm asking you for. We'll stick with 3 periods for now. Are you ready? If I'm asking you to forecast, I've got to get the number here. 1, 2, 3, 4, 5, 6, 7, 8. Period 8, which is year 3, season 2. Period 8. This is number 8. What numbers would you use? Not periods. What numbers would you use? 22, 41. 2306.
And 1105.
1105. You add them up and then divide by 3, and that's your forecast for period 8. Did she make a mistake?
No, I have a question. Why are we using future data to forecast something that already happened?
What future data we use?
So what we just did, we had to use.
This is all real data.
So year 3, season 2 is 2306.
Right, year 3, season 2, right here.
Right.
There's the forecast right there.
So
That's not a forecast.
but then you have to go down another one to something that happened after it to forecast.
Yeah, but all of this has already happened. This is all past data. We're here. This is real. This would be current down here. All past data. And the only reason we're using past data to get forecast is because we have to compare our forecasting technique to the actual. We have to use all the past. Eventually, we'll get down here to do forecast, but we got to do all of this centered moving average. The reason why, let me get to the reason why. If we were doing the whole problem, you'd realize by getting these centered moving averages, it allows us to compute what's called a scaled seasonal index number. We use the scaled seasonal index number to get the season out of these numbers. Look at these numbers. This 1886 represents this period, which the actual is 1105. But if you took the season out of it, it's 1886. This data is the same data you're looking at over here, but the season's been taken out. Do you see something happening with this data through time? What do you think is going to happen for the next year, 3 seasons next year? Is the data going to be larger or smaller? Larger. You see the trend, right? If we were to go full out on this one and go all the way through, once we get here, we then find our slope and intercept. We then forecast, let's say we want the whole next year. But then we got to do the math to take the season back into this forecast and get them back to where they look like this. So all of this is to get to the point of being able to do forecast when there's seasons involved.
So there is a step on this where you are able to forecast something happening in the future.
Exactly.
Okay.
And the deal is you got to put the seasons back in so it makes sense. Because when you do it, it's going to look like these numbers, which are not actual. This is if the seasons didn't exist. Take the season out, put the seasons back in. Which, by the way, most companies have to do it this way. Most companies do have seasons. So you've got to figure out what the seasons are. If this whole story were given to you, This company says, we're making season one our second biggest sale period time period, which is right around Father's Day. So they went in and said, we're calculating all the sales from this date to this date because we're all related to Father's Day. We have a really good Father's Day. I think it's neckties. This company sells neckties. Then the second piece of data, if we read the whole story, is that this season represents Christmas. Maybe I got it backwards. And so it gives the dates from here to here, right around Christmas time. We're calling that a second season. The third season, it's not Father's Day, it's not Christmas. The whole rest of the year, this is all they do. 95, 1,000, it's much lower. This company works the whole year just to get to Father's Day and Christmas to make money. Because the rest of the year, the sales are so low, they're not making any money. And so they call those 3 seasons. Because they have fluctuations in what would be normal. But what I want you to focus on is this centered moving average. Well, everybody, if you feel confident that if I told you which period I want to forecast for, which period numbers you would use to do the forecast. Do you feel okay with that?
Yeah.
Okay, here's a twist.
You always give us an odd number, right?
Yeah, that is the twist. The twist is, and you'll see posted on Blackboard, it will say centered moving average or something like that, forecasting with even number of periods. What I just showed you is if it were odd. If I said do a 3-period centered moving forecast, or if I said a 5-period, 7-period, 9-period, you do it exactly the way I just described. You use however many periods where the period you're forecasting is in the middle. If I said 7, if I said do a 7-period, hang on a minute, this period right here, it would be these 3 above it, 1985 all the way here, plus this one and the 3 below it. That way, if you're doing 7-period centered moving average, this would be the 7. Now, here's the hard part. If it's an even number of periods, 4-period centered moving average, 6-period, 8-period, there's an extra step because you can't forecast right in the middle of an even number of periods. Look at the first 4 periods here. Matter of fact, I want to go to this data. I want to go to this one now. Look at this. I say, use a centered moving average to forecast period 3. All right? Forecast period 3, we're going to use a centered moving average, 4-period centered moving average. Okay, blah, blah, blah. Are you ready? You got to use 4 periods. I'm saying just come up, how about this? Come up with your first forecast. Whatever the first forecast you can get with a 4-period centered moving average. I'm going to use the first 4 numbers. 17 plus 21 plus 19 plus 23 divided by 4. All right? Hang on, where are we at? 1, 2, 3, 4, 5. These are the periods. 6, 7. 1, 2, 3, 4 was used. Right in the center of these 4 is right here. Your forecast is between 2 periods, 2 and 3, because that's the center of an even amount of periods. Shift down. Now we're going to use 21 plus 19 plus 23 plus 18. Is that the next one down? Divided by 4. You just use period 2, 3, 4, 5, right in the center of these 4 periods, between 3 and 4, is that forecast. Whatever this equals goes right there. Whatever this one equals goes right there. You haven't got the forecast yet for any period. You found the forecast between 2 periods. And so this extra step, has to be done if there's an even number. I now got to add these 2, divide by 2, and now you just found the forecast for period 3. The extra step to get it lined up on a period number is you're taking the 2 centered ones that are not lined up, add them together and divide by 2 to finally line one up. I want to make sure you get this. So we're moving down. We're going down another one. I'm going down another step here. Make sure you get this. So now I'm going 19 plus 23 plus 18 plus 16. Does that look right? Divided by 4. So I just used period 3, 4, 5, and 6. So whatever this equals, 3, 4, 5, 6, is right between 4 and 5. Right there. Bless you. Hang on, there's 2 more. Man, I just got another one. Between 2 periods, I can now add those 2. Even though that was used for this one, I add these 2. I now just found period 4's centered moving average because we have an even number of periods we have to use. The extra step is you got to use, just like odd period, but they're lined up between 2 periods. So then you're using 2 at a time. 2 at a time. This does not matter how many. If this is 4 period, 6, 8, 10, you're only using 2 at a time to get the actual centered moving average lined up with a period. So because we have these 2 that surrounded 3, add them, divide by 2, we just found period 3. Because we have these 2 that are on either side of 4, add them, divide by 2, we just found period 4. That's the extra step on even number centered moving averages. So I just got to confirm you got this, and we'll be done with all of our new information, and we can start going over what to study for the final. All right, I want to make sure you got this. Hang on, I got to think. 4 period centered moving average. I got to think about it. If we were to do one more, here we go. One more, it would get us right here between 5 and 6. But now we have the ability to find the centered moving average for what period? Not between 2 periods. We just got the ability to find the centered moving average for what period? 5. Because we have it below 5 and above 5. We add those 2. Because we went another step, we now have the information to get period 5. All of these between periods had to use 4 periods. Well, when it's an even number of periods, this next step is always just using 2 periods. If this could have been 6 periods, 6 periods, 6 periods, you're still just using 2 on that next step. The extra step is because it's an even number of periods. I want to make sure, if you have any questions on this, that you open up the information about even number of periods that I put up there as a description. You start emailing me questions if you're not getting it, and we'll figure it out. Because I want to make sure you get this. This is centered moving average, and because the other class doesn't have to learn this, this is a good question that will be on your final probably, because I make the 2 files different. This makes it easy for me because they didn't even learn this. Any questions? Should we start going over the list?